So thanks everyone for joining us for the webinar today. Today we will be showcasing Softtree Optimal as a design tool interfacing with Civil 3D. So for our Civil 3D interface webinar today, here is a brief outline of what we will be covering. I'll be doing a quick introduction, and then I'll pass things on to Craig, and he will show you the Civil 3D interface to Softtree Optimal, bringing in the design from Civil 3D, setting up design parameters, doing the optimization, and then going back to Civil 3D at the end. So for a quick introduction, what is vertical alignment optimization, and what is Softtree Optimal? Softtree Optimal optimizes the vertical alignment of a road or corridor by mathematically minimizing earthwork costs. So it solves the complex 3D problem of minimizing excavation, embankment, and haulage given user-defined constraints. So this optimal solution is determined based on the original ground surface, the existing horizontal alignment, and the cross-sectional data taken from a Civil 3D design, as well as the design parameters, constraints, and unit costs entered by the user into Softtree Optimal. So the result is an optimal vertical alignment, detailed schedule of earthwork movement, and also a breakdown of your subgrade construction costs. Softtree is part of the Autodesk Developer Network, which has allowed us to develop a direct export interface that is integrated into Civil 3D. That's a little screenshot of what you'll be seeing today. And this interface allows Softtree Optimal to take in the surfaces, alignments, and cross-sectional data needed to calculate the optimal alignment. Once Softtree Optimal has been set up with the data from Civil 3D, the user is able to enter the design parameters, constraints, and costs, which are the last pieces of the puzzle needed to perform the optimization. And all of that is completely user-definable, which you will see today. So just a quick outline of the workflow using Softtree Optimal as a design tool. So the ability to generate an optimal vertical alignment for a Civil 3D design has benefits both at the beginning and at the end of the design process. So Softtree Optimal can be used for feasibility checking in the preliminary design stage. It can also be used as a means for quantitatively comparing multiple design variables at the preliminary design stage in order to determine the lowest cost options before getting into detailed design. So an example of this would be comparing multiple horizontal alignment options based on cost before getting into detailed design. And the detailed design can be done in your existing CAD design software program, whether it's Civil 3D or Inroads 12D or Softtree's easy-to-use road design package RoadEng. Softtree Optimal also is also useful to check a design at the end in the finalized design stage for design checking to perform a final optimization and determine the lowest cost alignment for a finished design, and also for estimating construction quantities. So the benefits of Softtree Optimal that you will see demonstrated in the webinar today can be summarized in construction costs, and ability to compare design options very quickly. And you'll also see how Softtree Optimal can give you access to costing in real time as you make design changes. And of course, all of this is without having to change your existing CAD software workflows. So with that, I will pass things on to Craig. And he will show you Softtree Optimal in action with the Civil 3D interface.
Okay, well, good morning, everyone. Thank you, Cam. Let's fire up Civil 3D. First of all, I have to put in a disclaimer. This is my second demo today, and so I might be a bit stunned at certain stages in this demo. The previous demo that I just did was with an Inroads project, so please be patient. Anyway, what I've got here is a Civil 3D project. It's a 10-kilometer rural highway, and as Cam mentioned, the key things to bring from the Civil 3D project are the existing ground surface, the alignments, and also the cross-section. And it's usually the cross-section that causes the greatest amount of problem. In the Civil 3D world, we're talking about assemblies and sub-assemblies. It's complicated stuff, and there is no land XML format that supports that. So what we've actually done is we've developed a plugin which automates the process of taking a cross-section from Civil 3D and bringing it into the Softtree Optimal environment, as well as the RoadEng, our design software environment. And here is the plugin. You can see it's on the toolbar here. And what this is going to do, and I'll explain this a little more when we get to Softtree Optimal, is it's going to sample the behavior of the cross-section so that we can preserve not only just the geometry of the cross-sections, but their behavior and logic. So before using this export function, I need to do a few things. I need to set up in Civil 3D some sample lines, which I've done. Just have a look here. I've got some sample lines set, sample line. And on the sample lines, I've sampled the original ground surface, existing ground. I've also put the corridor on there, as well as a corridor surface which I created with my corridor. So when the corridor is rebuilt, the corridor surface is built, and this is your standard corridor surface. And because we're doing optimization, I've only included just the subgrade surface, and that all is pretty standard Civil 3D stuff. So I've taken those items and I've placed them on cross sections, on sample lines, and you can just see here some of the sample lines. So this is a rural highway. It's got a medium in the middle, and it behaves. It's got different slope angles that change and so on. And these have been mapped onto these sample lines. So without any further ado, I will start an export process. And by the way, exporting the alignments is very simple. You can export them as land XML files. So I can just right-click, export to land XML, comes through very cleanly and easily. Surfaces as well, original ground surface, right-click, export to land XML. So that's pretty straightforward. What we're really worried about here is getting the cross-section information across. So I'm going to start this process, and I click in our plugin area. I click on the Optimize button. It asks me for the name of the alignment. I only have one horizontal alignment. Asks me for a sample line set, and again I only have one. Asks me for my design surface, which is my corridor surface that I spoke about a few minutes ago. And finally it asks me for the corridor which I want to export. Then I give it a deflection, vertical deflection of, let's say, 10 meters, and an increment. This is the spacing at which I'm going to sample vertically. I'll explain this a little bit more. So let's just start this going. It's going to take a few minutes. So instead of sitting here and watching it do its work, I'm going to minimize this. For a second, just move this out of the way, and I'm going to come over to Softtree Optimal. By the way, this is a new beta version, which I've been given, and I'm still stumbling around a little bit. We put in a new ribbon bar interface, all the same functionality, but the interface is just a little bit more modern. Anyway, I'm going to create a new Softtree Optimal design, and I'm going to specify a land XML file for the original ground surface, which I exported previously. This is straight from Civil 3D. It's going to read that in. It's not a particularly large surface, Sometimes it's better to work directly with, if you're working with LiDAR, to work directly with a LAS file, not using the land XML file. But that's really just an efficiency thing. So here in that file I had two services. I had the subgrade surface and the original ground. I'm going to pick the original ground surface. Some other options here, which I'm just going to take the defaults. It's going to bring in the land XML original ground surface. Save it as a terrain file, which is our internal format. I've already done this, so I'll just replace that. Then I'm going to choose for an initial alignment. I'm going to choose to get that from a land XML file. Again, I'm going to pick that same file because the alignment was in it as well. Read that in. And it's found the alignment in there, and this is my horizontal alignment, and this is the vertical alignment, which I showed you a minute ago in Civil 3D, which are saved out. And here is the crux, which is the cross-section. So instead of using a standard template, which is our version, which is a Softtree version of assemblies and sub-assemblies, I'm going to use what's called the corridor sections. And this is the magic here. Export data corridor sections, and I'll explain a bit further. Let's just read them in. Let's go ahead and do that. And there we go. Here is the same design now in the Softtree Optimal environment. We're pretty much ready to go. We haven't had to do any setup or conversions and stuff. A little bit of exporting, and we're ready to go. And let's just look at, here's our vertical alignment. Let's just look at some sections. Let's call up the section window here, and you can see the rural highway with the medium in the middle. But the interesting thing here is that if I go into the template editor, which is sort of a sandbox way we can explore how the template's behaving, I can move this cross section. I can move it vertically. And you'll notice that the ditch has disappeared. It's figured out based on what the Civil 3D assembly has done, what it should do when it's moved around. And that enables us to get a dynamic template from Civil 3D, to get a dynamic assembly without doing a lot of coding and setting target surfaces and alignments and yada yada. We get it. We get its behavior in this environment, and now we're free to do things like optimize. I should also say that my presentation here not only applies to Softtree Optimal, but it applies to RoadEng. People who've got RoadEng and use RoadEng because it's maybe a little simpler. This technique will allow you to bring in a Civil 3D design and review it in the RoadEng context and do things like maybe just design checking or as-built quantities, pay quantities, that sort of thing. So it enables you to do a civil design and do your work here in a lighter, more friendly environment. So that's the cross section, and now let's get into the fun stuff, which is optimizing this alignment. So I'll switch over here back to the profile window. And on the right-hand side here is our alignment properties panel, and this is where we do optimization. So the first thing I want to show you is I'm just going to clone this alignment, create another alignment. And the first concept that's important to understand about optimization is that of cost. There is a cost. And for this alignment here, for this original alignment, I've calculated, or Softtree Optimal has calculated a cost of about $8 million, $7.9 million, cut costs, fill costs, haulage costs, and the haulage costs are broken down into different categories. So how is it doing that? It's using cost factors, not exactly rocket science, but for each type of material you've got an excavation cost in dollars per cubic meter, and similarly a fill or embankment cost in dollars per cubic meter. That's pretty straightforward. But the magic here is that we can calculate haulage costs based on different distances, free haul, overhaul, end haul. We've got haulage costs in dollars per cubic meter per kilometer, loading cost, and haulage costs. So with these costs and with the costs of the material, excavation, and embankment, we, or Softtree Optimal, determines the best way to move material around. And this is the result of some research work that we've been doing for quite a few years now with the University of British Columbia, is to come up with an engine which will very quickly calculate optimal movement of materials, which is kind of cool. So based on these costs, I've got a cost for this alignment, and I can change the alignment a little bit just manually here. Let me actually switch over. I want to perturb the original one. So I'm gonna change this alignment. There's the cost. Maybe just drop this down a little bit. It's going to recost, I think. That's maybe force it to recost. I didn't have auto turned on. Calculate this. Probably going to give me a warning, which I'll blithely ignore. And there I've got a new cost for my new alignment. And now when I move it again, you'll see that cost is updating. So there's a good feedback when you're designing to see, you know, what's going on with my costs. Of course, that process is trial and error, standard engineering, you know, methodologies. Just try things, look for improvements, apply engineering common sense. Let's now look at how that optimizer can even help us more. Set this back current. I'm going to delete this one just so that I don't get too confused. So a lot of people see the optimizer and they say, "Oh, this is a black box. I just push a button and I'm going to get an optimal alignment." This is the way this tool works. This is a tool that helps you do a lot of tedious things very quickly. It gives you a reference for something that you maybe have done and want to compare to what is optimal. It is in no way a complete solution by itself. It has to work with other things that you are going to consider, safety, drainage, and so on. So it's by no means a black box. So let's just create a new optimized alignment. So same thing, I'm going to create a new alignment. Oh, my mouse isn't working, but there we go. I'm going to call this user, because I'm going to use a specific type of curve definition, which is a user curve. And here we've got a station range, which we're going to optimize. We've got sample spacing, and I'm going to cheat a little bit. Forgive me. I'm going to go with a very coarse section spacing, 100 meters. If I go with a smaller one, it's going to take a little bit of time, and I don't think that's time well spent in this demo. Trust me, if you went with a finer, more accurate spacing, you get a more accurate result. This will give us a result, and it'll go faster. So I choose a very coarse spacing. By the way, optimization can take a long time. It's very unpredictable. It is possible to throw a 20-kilometer project at this with a very tight section spacing, and it takes all night to run. That's just the nature of it. You cannot exactly predict when it will find its solutions. Generally, though, you can get a good solution within minutes. Generally, I can't say much more than that. So the other things we entered here are minimum and maximum offset. That is the distance above and below the existing profile, which we want the optimizer to look in. And yeah, so the next thing I want to look at is standards. And this curves fast option is is fast and it gives you a very low cost alignment, but a lot of people don't like it because it's very curvy. So I'm going to choose user defined, which is going to choose the curve positions, or the stationing positions of the curves based on the curves that I already had there. So it's going to keep the same curve positions horizontally, but it's going to look to optimize those. In here, I'm going to set some grades, and I made a note of these somewhere, which I can't seem to find. Oh, here we are, minus 5.25. These were real live grades that we got. And the sag and crest values that I want are both 60. So those are my grade constraints. I don't want to go over 5.25, and that's my sag and crest curve values. And the other sort of nuts and bolts thing that I would add here is control points. For this alignment, I'm coming off an existing road, so I want to match the elevation at that point on the road, and I also want to match the grade there coming off. And the same thing at the end of the road, and I want to match the grade there as well. So I've put in 2 control points. Oh, sorry, I didn't get that. And obviously I can do this at other places along the road if I had a utility that I had to cover, or anything, a bridge location. I could force a control point there to do it. So let's just do this. There, I've got my new alignment. Let's just press the process button. Go ahead and do this, and hopefully, I think I ran this before and it ran quite quickly. Otherwise, I may have to tell you a few jokes or something. There, that was quick. So we've got what's called an optimality gap of 1.7%, which means in the worst case, I'm 1% away from the very guaranteed lowest solution. And here's the cost it's got so far. I could let it run all the way to 0, and that would guarantee me the optimal solution. But I'm going to say, well, I'm happy with 1%. Let's have a look at that alignment. So I'm just going to cancel out of there. And it does a bit of post-processing, throws up some crazy-looking numbers, and eventually it gives me some warnings, which I'm not going to dwell on. I can tell you they're innocuous. And there we go. There is the alignment that's been optimized from the curve positions of the original alignment. But if we compare the costs of it, it's going to be cheaper. And it is. It's 14% cheaper. So there's what's a savings? A fairly good savings in terms of just dollars. Of course, this is based on those costs that I put in the first place. You may say, well, I don't have good costs. Well, that's okay too, because you're comparing 2 alignments with the same set of costs. So in general, it's a fair comparison, even if the costs are realistic. So that very quickly is an optimal alignment. I can then take that alignment and go back to Civil 3D and do some final design on it, drafting, and so on. I can also try different things here. This is a great place to try different things. Let's try a different type of curve. So I'll create a new curve. I'll call this one C and T. And I will put in another type of curve, curves and tangents, slow, and I'll give it a minimum curve length of 100. And same control points as I had before. And by the way, I didn't mention this before, I should have. You can add pit locations anywhere along the alignment. They can be pits which we call smart pits, which suppose you had some sources of borrow and you knew where they are. You weren't sure if it was economic to use them. You could enter them here, and you would enter a station distance, a station access point, and a distance from the station. You'd also give it an opening cost for that pit, and you'd include the pit in the optimization. And the optimizer would decide whether or not it was economic to use that pit based on the distance, the hauling distance, and the opening cost. And at the end of it all, you'll be able to see which are the best pits to use if you have multiple pit sources to choose from. You also can use the pit facility to account for other volumes that may be coming into your project. Say you've got a side road, an intersection, some other earthwork that you need to incorporate at a certain station. That you would turn off variable pit, and you'd actually put in an amount of material or waste that you need at that station to account for construction that's not on the main alignment. So the pits here are very flexible, and just going to remove this. If I don't have any pits, it's going to try and balance the road internally. Okay, so what I've done is to create a new type of curve, which is slower than the user curves, but it gives the optimizer a chance to put curves in where it wants. I've told it that the curve length, minimum curve length, is 100 meters, and I've got the same control points, costs, and so on. Let's just go ahead, do this process. Hopefully it's going to run quickly. I think this does. Just to give you some idea of different options that you'd have as a designer. This completes fairly quickly. I'll try one more thing there. Okay, good. We've got a solution. Usually when it gets a solution, it converges fairly quickly. One of the other things that we can do is to try different design speeds very quickly. Suppose you've got an alignment, you've got some K values, and you want to know that costs so much. What if I increase the design speed, try another K factor? What's it going to cost? What's the incremental cost of making a better road? Rather than wait for this to go, I think I'm just going to cancel it, knowing that this is possibly a better solution. We can just have a look at what it's got so far. So once you've got a solution, it'll show an optimality gap, and you're able to cancel and still get an alignment. By the way, Cam, are you monitoring questions?
Yeah, I'm monitoring questions. There is one here, actually.
There is one?
I have been watching, but I didn't see that one just yet. I'm just pulling it out here. Okay, well, I'm going to start another optimization just while you're doing that. So I'm going to try changing I'm going to up the standard of this road. Let's go up to 80. It should get more expensive, obviously. And yeah, let's just go ahead and do this while you're fishing the question out. All right, I got it here. Are you ready for the question? I'm ready. In cases where the overground common material is not suitable, or OG common material is not suitable for road construction, can the station ranges be set to prevent cuts? For example, in areas of wetland, solid rock, or sand where you need a specific amount of embankment fill and cannot have a cut? Yes. Yes, you can. As soon as it's finished, I'll show you a couple of things along those lines. There's quite a bit of flexibility in how you handle materials, whether material is usable. You can also constrain the optimizer to overland in certain sections. There's all sorts of controls that you have, and I'll show you some of them. I'm going to cancel this one as well, just for time purposes. Cancel. It does. It's got some scary looking numbers there.
Okay, again, I'm going to blithely ignore the warnings. So there is another alignment, and if we compare, this is 448 total cost, 46. So it got more expensive as you'd expect it. It's a higher speed road, and that was the difference. I mean, you could calculate the difference in various categories. But back to your question, two answers. One is let me get rid of this. This is, by the way, this is the results from the export that I started originally. I'll come back to that. Yeah, so one of the things I can do is to go into Edit Templates. Sorry, so let's look at a section, and let's go to a section. There's a section there. I can apply stripping to this, and so I can strip away overburden material that's unsuitable before this is placed in there. To do that, I go to Home, Sign by Range. I could sign some stripping. Sorry, I'm just a little bit unfamiliar with this new interface. 0.5, and I'm going to say on the outside, I'm going to go out to the slope stake base. Inside, it'll be center line. Okay, so I'll apply 0.5 meters of stripping. We can calculate that. And there you can see that material now has been stripped and taken out completely out of the mass haul, out of this calculation. So the fill volumes are increased, and we have a separate strip material. So that's one thing. But I think what you were alluding to in your question was controlling the optimizer. So I can put in there's lots of different constraints you can say. You can put in a minimum fill constraint. So between such and such a station and such, I want to have a certain amount of fill. I want to have, I'll make this active, I want 1 meter of fill between one station and another. I activate that constraint, apply it, and optimize, and it will honor the constraint and stay above 1 meter above the ground in that station range. It's really up to you. What you want to try and avoid with optimization is over-constraining the problem. So the more flexibility you give it, the more it can help you. An example of that might be you have a driveway or something you want to match with the optimizer. You need the alignment to be able to get into the driveway. Rather than say, I want the elevation of the alignment to be an exact number at that station, you tell it, I want to be at that elevation, but I got some tolerance. I got a few meters, 3 or 4 meters of tolerance to get into the driveway. So you're giving it more flexibility, and the whole thing is the least constrained problems are cheaper. You know, the optimizer looks and finds cheaper solutions, so less constraints is good. It's also possible to over-constrain a problem, to give it constraints that are impossible. I want to go through these control points, and I want to have this K value, and I want these grades, and you've got too many control points, and you go to optimize it, says no solution found. It's infeasible. It's simply geometrically impossible to do what you've asked. You can't. So having you determine situations that are infeasible. Okay, how are we doing for time here? Oh, I might make
okay, Craig, I think you're okay. We've budgeted 45 minutes for this one. So
okay.
A few more minutes.
Okay. I have a bad tendency for going way
I didn't
overboard.
tell you at the beginning.
I can talk for days. Okay, so some other things I wanted to show you were we've got these different alignments, and let's just have a look at one of these. I'm going to set it current. The one that's current right now is the original. It's the one in bolded. I'm going to set this current so I can see the mass haul graph for it. And there's my mass haul graph. I guess that's because we've got a lot of, that doesn't look right. Let's pick one that I ran right to optimality. still looks a bit, not sure why our mass haul is so badly out of balance. It shouldn't be. I've obviously done something I shouldn't have done. It could also be the very coarse section spacing. Is the mass haul is based on a tight section spacing, whereas the optimization was done on a really crude section spacing. So if I'd done this properly, if I hadn't cheated, we would be seeing, because I don't have any pits, we'd be seeing a mass haul that was very balanced. That's not the case. The other thing I wanted to show you is that I can have a new type of graphic which is quite useful for seeing how material is moving. And that is what we call the OptiHaul graph. It's down at the bottom here, and it's showing material by class. So there's very little, this is free haul material. You can see the direction that material is being moved in a free haul way. And then this bar here is overhaul. See how it's been moving. And finally, the bottom one is end haul, and you can see that. And this table is based on optimal material movement, and you can print it out and bring it into a spreadsheet or copy it, paste it into a spreadsheet. So yeah, if anyone's interested, I could find out why this is so badly out of balance. I suspect it's the section space. So the final thing that I wanted to show you is how to save this out as a DWG file. Sorry, not as a land.xml file. So it's very simple. Save this, choose land.xml, so I can bring it back into Civil 3D. I call this optimized align. It's an XML file. And I don't need sections with this. I've got all that already in Civil 3D in the original. I'm just going to save this out. There it is. Now if I go over here, oh, I'm in the wrong folder. That could be it. And there's my XML file. And of course, I can go to Civil 3D. By the way, during my presentation, the original export completed from Civil 3D, and it put the files that I used initially into a folder, and here they are. And I could then just start up with those. So it took a few minutes, but it did create those files from my original export. So back to Civil 3D, let's go and pick up that alignment file, insert land.xml, and there's my optimized alignment. I just bring it in, and I look under my alignments tab, and it's called Untitled. For some reason, I know why it's called Untitled, because my design, I hadn't saved it, it was called Untitled. So it takes on the name of your design. But there it is, and of course I can update my corridor based on that alignment. And how do we do that? Properties. There was my original profile. I need to change this first. So I need to change this to Untitled, and then I can choose my profile from Untitled. There you go. Rebuild the corridor, and you're back in action in Civil 3D with an optimized profile. So that's the workflow. Civil 3D is busy thinking here. when it resurfaces, we will have a rebuilt, there we go, rebuilt corridor based on the new alignment, and of course the sample lines have been resampled. It's all good. The profile you need to regenerate, because this profile was based on the original profile, so you would need to recreate the profile, but that's pretty easy. I understand. I'm not a Civil 3D expert, but yeah, that's the end of my presentation. Are there any questions, Cam?
Doesn't look like there are any more questions. I'm just going to quickly switch back to my screen and show you a list here of our upcoming webinars. Thanks for joining us today, and hope to see you all again in the next few weeks.
Cam, just a quick update. I just reran the optimization here. I increased the interval to a more reasonable spacing of 25 meters, and I set one of these optimal alignments to my to be current, and right away I get a very good balance. So the problem I had a few minutes ago was just simply the spacing wasn't good enough. That's all. Thank you, everyone.
Have a great weekend.